Oh, I got a whole bunch of your homework graded. I'm sorry, I was so behind on getting those grades done, but with moving and everything, it just kind of was nuts. So I got your homework graded. If you have not uploaded some homeworks, I didn't give zeros for them missing homeworks. Just make sure you get those uploaded. But I did get obviously those grades upgraded. I still need to put in grades for attendance. That's the one thing I haven't done yet, and I apologize, but I will get that done probably next week. It's probably not going to happen before next week, but it will get done soon. And I apologize again for the delay. So today we're going to finish 5.5, and then we're going to do 5.6 as well. And so we are going to pick up on page 87 of your notebook. So I'm just grabbing the 5.6 stuff so that we can move forward. All right. So the second part of 5.5 is adding and subtracting with fractions and decimals. So there's two ways we can do this. We can either choose to convert everything to a fraction and then add them together, or we can choose to convert everything to a decimal and add them together or subtract them. My suggestion is if the fraction terminates, meaning the fraction is convertible to a terminating decimal, then it's fine to convert both to decimals and add or subtract them then. However, if the fraction does not convert to a terminating decimal, meaning it converts to a repeating or non-terminating decimal, then it's better to convert the decimal number to a fraction. So here's what I'm talking about. In number one, I have 3/8 plus 3.45. So if I take 3/8 and I convert it to a decimal, that means I'm going to take 3 and divide it by 8. Remember, in order to do this, I have to add a decimal and add that 0. 8 goes into 30 3 times. Eight goes into 60 7 times. And 8 goes into 40 5 times. And we can see that our decimal terminates, right? Because we get a 0 when we're doing the division. Therefore, instead of having 3/8 plus 3.45, we can say 0.375 plus 3.45. And because that decimal number terminates, we're okay. Now we can just add them as we would. So remember, in order to add decimals, you have to line the decimal points up. And we want to add these. There's not a value here, so we're going to add a 0 there. So every column lines up. 5 plus 0 is 5. 5 plus 7 is, what is that, 12? 4 and 3 is 7 plus 1 is 8. Bring my decimal point down, and we get 3.825 as our answer. The alternative was that we could have left 3/8 as a fraction, and we could have added to it 3 and 4 45 100ths, or 3.45. So that would have looked like this. And what we would have needed to do there was find a common denominator, and then we could have added these numbers together. So there will be problems where it's better to do it this way than to do it the decimal way. But for number 2, you're okay to switch 5/2 to a decimal and then subtract. So go ahead and do that. So again, if after you convert 5 halves to a decimal, go ahead and actually subtract those two amounts, okay? So remember, converting to a decimal, we're going to take our numerator and we're going to divide it by our denominator. So 2 goes into 5 twice. So 2 times 2 is 4. Go ahead and subtract, bring our 1 down. Since we haven't, we don't get a 0 there, we need to keep going. So we're going to add a decimal point and add a 0. So if I had the decimal point here, I have to add it here as well. We'll bring that 0 down, and 2 goes into 10 5 times. And that goes in evenly. So 5 halves is equal to 2.5. So we're going to rewrite this as 2.5 minus 7.63. So we know that we have a larger number that we're subtracting from a smaller number, meaning our answer is going to be negative in the end. But what we want to do is just subtract these numbers normally. So we're going to do 7.63 minus 2.50. And again, I had to add that 0 so that we have a number in each of the columns. 3 minus 0 is 3. 6 minus 5 is 1. Bring down that decimal point. 7 minus 2 is 5. But we need to write this as a negative number because I'm taking 7.63 away from 2.5. So we end up with negative 5.13 as our answer. So I got a couple different answers when people were sending me. Are there any questions about that one? Because remember with subtraction, we always have to take the smaller value away from the larger value. But we have to keep in mind, is the overall answer going to be positive or negative, depending on which is the smaller value and which is the larger value. Okay, so 1 and 2, we could convert both of those fractions to decimals, and it worked nicely. 3 and 4, we can't. Denominators was 6. And denominators of 9, they do not work. So what that means is we have to convert the decimal number to a fraction. So for 3.5, the 5 is in the 10th position. Therefore, 3.5 is equal to 3 and 5/10. Okay. This obviously reduces. We can say that this is equal to 3 and 1/2. And reducing that value will be helpful because we now need to turn this mixed number into an improper fraction. So to do that, we're going to do 2 times 3 plus 1. So 2 times 3 is 6 plus 1 is 7. So we get 7 halves. We're going to have negative 5/6 plus 7 halves. And again, remember when we're adding and subtracting with fractions, we have to have a common denominator. We don't need the common denominator with multiplying and dividing though, okay? That was a common mistake on the, what was it? The quiz that you took before spring break. That was a common mistake that I saw. So for these two fractions, the least common multiple or the smallest number that both 2 and 6 divide into is 6 itself. So we only have to convert the fraction on the right to a fraction with a denominator of 6. In order to do that, we need to multiply the 2 by 3. Remember, whenever we do the denominator, we have to do the numerator. So we're going to multiply the numerator by 3. So we're going to rewrite that 5/6, negative 5/6, excuse me. And then 7 times 3 is 21, over 2 times 3 is 6. Negative 5 plus 21 is going to be positive 16 over 6. And then we don't want to leave it that way. We want to convert it back into a mixed number. So 6 goes into 16 2 times with a remainder of 4. We want to reduce our fractional portion. So 4/6 reduces to 2/3, right? Because both 4 and 6 are divisible by 2. And this is going to be our final answer. So let's talk again about our process. What did we do? We first converted the decimal number to a mixed number, right? The decimal portion became that fractional portion. Then we took our mixed number, we reduced it just so we had smaller numbers to deal with. Then we converted it to a mixed number to an improper fraction. Then we were actually able to add those values together. We had to find a common denominator, right? That was this step right here. And then once we had the common denominator, then we could actually add, and then we had to convert our final answer from an improper fraction back to a mixed number and reduce. A lot of steps there, right? Okay, so I want you to try number 4. You're going to have to convert that decimal number into an improper fraction and go from there. I suggest reducing your fraction before you try to find a common denominator. All right, so again, 7/9, if I convert that to a decimal, it's going to be 0.7 repeating. So you want to instead convert 4.25 to a fraction. So this is going to give us 7/9 minus 4 1/4. We're to convert that 4 1/4 to an improper fraction. So that's going to give us 7/9 minus 17/4. So now we need to find the common denominator for these. So that's going to be the smallest number that both 9 and 4 go into, which is 36. So to get that, we're going to multiply the left fraction by 4/4 and the right fraction by 9/9. 4 times 7 is going to be 28. I wrote 29 for some reason. So 28/36 minus, and 17 times 9 is 153/36. So if we subtract these, we're going to take 28 from 153, which gives us negative 125/36. And again, I know it's negative because I'm taking 153 away from 28. 153 is a larger number, and therefore my answer will be negative. Converting this back into a mixed number, 36 goes into 125 3 times. It's going to be a -3 because again, that fraction is negative. And then this will give us a remainder of 17/36 as our final answer. So again, if you convert that fraction to a decimal and it doesn't terminate, it just keeps going, it repeats, then that means you have to convert the decimal number instead to a fraction and then deal with them. So what questions do you have before I move forward into 5.6? Okay, so 5.6, I want you to notice now after 5.6, any quizzes or tests, or even while we're in class, you can use a calculator now. If you have been using a calculator up till this point, we're going to pretend I didn't know that, because this is the point at when you are officially allowed to use one. So, and the reason for that is we're dealing with decimals a ton. We're solving equations. We want to focus on the equation solving part and not trying to multiply these decimals by hand and things like that. So number 1 has 0.4x minus 0.68x. So we need to combine like terms. When dealing with these solving equations, just because there's decimal doesn't mean that our process changes at all. We still follow the same steps. So I'm going to do 0.4 minus 6.8. So this is going to give me, when I combine these together, I get negative 6.4x equals 3.2. I'm going to divide both sides by negative 6.4. And when I take 32 or 3.2, excuse me, divided by negative 6.4, I get negative 0.5 as my answer. Okay, so think about what we did in number 1. Now I want you to try number 2. And number 2, what's different is that we have variables on both sides. Remember, when we have that, we have to get our variables together on one side, get the non-variables or the constant terms to the other side, and then solve, okay? So go ahead and try number 2. Okay, so like I said, we want to first get our like terms together. So what does that look like? Well, first we're going to subtract 2.9x from the right-hand side and subtract it from the left-hand side. So what I'm doing is I'm moving my x's over together. So subtracting them, 3.4 minus 2.9 is going to give us 0.5x. Bringing down what we haven't used, which is the minus 4.8, equals 3.6. We're now going to add 4.8 to both sides. Bring down our 0.5x, and 3.6 plus 4.8 is 8.4. So the last thing we're going to do is we're going to divide by 0.5. And we get 16.8 as our answer. Okay. So number 3, zoom out in case you're writing down those steps. Number 3, we have a value in front of our set of parentheses. And remember what that means is that we have to distribute that value through, meaning we have to multiply everything inside by that value first, and then we can solve for x. So go ahead and try that one. So if you've already sent me your answer for number 3, go ahead and move on to number 4. Okay, so let's look at number 3. Number 3, we're gonna have to distribute this 0.5 through. So we're gonna do 0.5 times 1.5x minus 0.5 times 6.58 equals 6.88. 0.5 times 1.5x is going to give us 0.75x. 0.5 times 6.58 gives us 3.29 equals 6.88. We're going to add 3.29 to both sides. We'll bring this 0.75x down because we haven't done anything with it. 6.88 plus 3.29 is going to be 10.17. Then I'm going to divide both sides by 0.75. And I get 13.56 as my answer. So looking at number 4, this is one where we have to combine sort of everything we did in 2 and everything we did in 3. So here we're looking at needing to distribute first. So 1.1 or negative 1.1x plus 1.3 times x plus 1.3 times 1.3 equals 19.88. Simplifying, 1.3 times 1.3 is going to be 1.69. And we're going to combine like terms. So we're going to do 1.3 minus 1.1. The reason I'm subtracting those is that the 1.3 is positive and the 1.1 is negative. So we need to find the difference between the two. Because 1.3 is positive and it's the larger number, we're going to get 0.2x, which is positive, as our value. We're going to subtract 1.69 from both sides. And we get 18.19. And then lastly, we'll divide by 0.2. And we get 90.95 as our final answer. Whew, lots of steps, right? All right, so now we're going to go on to 5.6. Well, we're still in 5.6, but we're going to look at the word problems. And so I'm not going to bother to read through that first part. It's always the same, telling us when we're solving these word problems, we have to define our variables and set up our equations. Sometimes it helps to draw a picture. You solve it. You got to go back and say, did I actually even answer the question? Does my answer make sense in terms of the question? All of that stuff. So let's just jump into them. Hannah runs a business out of her home making dolls. Each month she has fixed costs of $180. In addition, for each doll she makes, she incurs an additional cost of $1.75. If her total cost for the month was $208, how many dolls did she make? So there's a little background information we need to understand. So fixed costs are, that's like just what she has to pay no matter what. So that's like what she pays for utilities and things like that. That's going to happen. That's going to be a charge no matter if she makes $1 or $100. That's just, those are her fixed costs. Those are happening every single time. Her total costs are going to include the cost per doll. So we're going to go ahead and say D equals doll. And C equals total cost. So we can say that she's got 1.75 per doll plus the fixed cost of 180 equals her total cost. They tell us now in the second part what her total cost is for the month. It's 208. So we can say 1.75D plus 180 equals 208. And from here, We want to solve for D. I'm going to let you go ahead and finish that on your own. Let me know what you get for D. Okay, so we're going to subtract 180, excuse me, from both sides. Bring down that 1.75D. 208 minus 180 gives us 28. Divide both sides by 1.75. And D is equal to 16 dolls. So she made 16 dolls. All right, so let's go to the next page. We're going to skip 2. We'll come back to that in a minute. But we want to look down at number 3. It says, after extensive market analysis, Hannah has determined she can sell her dolls for $9.95 each. Using the same cost as problem 1, determine the number of dolls Hannah must make each month to break even. So if we go back to our previous page, she has fixed costs of $180 and a cost per doll of $1.75. She wants to sell the dolls for $9.95 each. So profit is going to be the amount she makes per doll, right? D is still equal to dolls. P means profit. And we know our cost function from the previous page was $1.75 D plus 180, right? So what it tells us is the break-even point is when the total costs equal the total outcome. So, or the total income, excuse me, or profit. So what we would do is we would say 9.95D equals 1.75D plus 180. So go ahead and solve for D and we'll go from there. Okay, so we're going to start by subtracting 1.75 from both sides. This gives us 8.2 on the left-hand side and 180 on the right-hand side. So dividing by 8.2 on both sides. So 180 divided by 8.2 is 21.95121, and this is a repeating decimal. Now, we can't have 0.95121 of a doll, right? But because we want to make sure that she breaks even, she needs to make sure that she sells 22 dolls. The reason we round it up is A, it's closer to 22 to begin with, and B, if we were to say she only needed to make 21 dolls, that's not going to give us enough money to break even. She's still going to be a little bit in the hole. And when we're saying breaking even, that means that she's making enough money so that she's covering the cost per doll to begin with at $1.75, and she's covering her fixed costs. Okay, so she needs to make at least 22 dolls. So any dolls she makes above 22, she's then turning a profit and she's actually earning money, versus if she's making less than 22 dolls, she is not turning a profit. She's still she is in the red, as they say. Okay. All right, let's jump back up to number 2. So Heidi has 45 feet of decorative fencing, which she will use for the border of a small circular garden. So let's see, we've got a garden. It's a terrible thing drawing, but we're going to put a fence around it. The reason why I'm not an artist. It's a very rough fence.
You crack me up.
I have to entertain myself somehow, right? We're going to put some flowers in here. Oh yeah. We could sell this thing as an NFT, right? Nobody's gonna have this. Incredibly rare. Just kidding. Anyways, so there's my garden, okay? And I got my fence around it. Now Heidi, or me, whoever, we have 45 feet of fencing. And so that means the distance around this garden is 45 feet. So what is the distance around a circle considered? What do we call that? Think back to what we were doing on Monday. What were we doing Monday?
Is it circumference?
It is circumference, yeah. So the circumference of a circle, we can find that 2 ways. We can do it diameter times pi. And for pi, you can see it's telling us to use 3.14. And remember, the diameter is the distance straight through the garden, but it says find the diameter, so we're okay. So we know that the circumference is equal to 45, and we've got the diameter, and we need to solve for D, and it says round to the nearest 100th of a foot, so 2 decimal places. Go ahead and solve for that. Okay, so if we divide both sides by 3.14, we get 14.33, oops. One, 21019 is equal to D, but we want to the nearest hundredth, so we're going to do 14.33. And remember, with these problems, you have to make sure you include your units of measure. So going back, we'll see that we have feet as our unit of measure. So the diameter is equal to 14.33 feet. Okay, so that is, let me make sure that I'm not stopping us soon. Too soon. What's today? Yep, I was only supposed to go through 5-6, so we'll do 5-7 and a little bit of 5-8 on Monday. The nice thing about 5-8, I'm just exposing you to it. You don't actually have any homework to do with it, okay? So today, you don't have anything to do. If you didn't get your test 3 done yesterday, please go and get that done. Your homework for 5-3, 5-4, 5-5, and 5-6, all of those is due Monday, okay? So that is all I have. I hope you have a great weekend. Email me if you have questions, okay?
Thank you.
You're welcome. Bye, everyone.